Welcome to part 2 of chapter 4. We're going to start talking about different types of forces that we'll encounter all the time in problems. One is what we call the normal force. So when we put this bag of bow wow chow, okay, so when we put this bag of bow wow chow on the table, the weight of the bag pushes down on the table. What we call the force exerted by the table on the bag, the force upward on the bag, we call that the normal force. Now, normal, usually we give it a symbol N, or N with a little arrow over it. This normal force is, the word normal means perpendicular, right? So the normal force is always perpendicular to the surface. And think about it this way. If we take this table and we turn it over, right? The tabletop no longer exerts a force on the dog food, right? So let me draw this for a second. So if the table, if the table is like this, and you put the dog food here, well, since a normal force can only be perpendicular to the surface, there is no normal force anymore because the weight of the bag is pointing downward still, right? And since there's nothing counteracting the weight of the bag, what happens to the dog food? It falls to the floor, right? So normal force is always perpendicular, always exerted perpendicular to a surface. It's the surface of your chair, the surface of my desk, holding up my computer, as you walk across the room, as you go up a hill. And this is why when you go up a hill, and we will get to problems like this, but if you're walking up a hill, well, the normal force can only be this way. And as the hill gets steeper and steeper, all right, there's less that the normal force can do for you in terms of helping you stay on the hill, and you get to where you begin to slide down the hill, right? Another force we'll talk about all the time is tension. Now, tension is an interesting force in that if we work through what happens with tension, tension is always on a rope that is tight. The tension at one end is always equal to and opposite to the force of tension at the other end, right? So here's this person holding a rope. There's a force downward exerted by the rope, and down here when you get to the mass, there's a force upward exerted by the rope. So tension is one of those forces that flows along a taut rope, right? Flows along a taut rope. So problem-solving strategies. How do we do these? And mostly you'll figure out how to do these as we go through them, and we work through them in class. But identify the type of problems and which of Newton's laws are involved. Right? This is an important thing. Which of Newton's laws are involved? What is going on in the problem? You want to draw a free body diagram. You want to identify all the forces in the free body diagram and make sure you understand which ones are internal to the system and which ones are external to the system, right? Identify what needs to be determined and what is known or can be inferred from the problem as stated, like starts from rest means initial velocity is 0, right? Or comes to rest means final velocity is 0. So you can make a list of knowns and unknowns and carefully determine the system interest once you have your free body diagram. Once you know what you're after, then you can use Newton's laws to begin solving the problem. So here's a drawing of a problem, right? Newton's laws as applied to a traffic light suspended between two poles, right? So here's the system of interest. What's happening to the traffic light, right? The external forces on it. The weight of the traffic light down, the tension on the guide wire going this way, the tension on the guide wire going that way. And so how do we figure out what is going on, right? Well, I'm assuming we know the weight, right? We know the weight of this, or we can weigh it. We know it's not accelerating, so if we look at the net external force on our light, it has to be 0. So let's look at the vertical direction. Vertically, we have the weight, right? The weight coming down this way. And we have the component of T1 that goes this way, and we have the component of T2 that goes that way, right? And so vertically we say for it to not be going up and down, the total net force has to be 0. So T1 sine 30 degrees, which is its vertical component, plus T2 sine 45 degrees, which is its vertical component, have to be exactly equal to the weight in order for those to cancel out. Horizontally, we also say, look, it's not moving one way or the other, so the net force horizontally must be 0, right? So we have here T2 times cosine 45 degrees, if we call to the right the positive direction, minus T1 times cosine of 30 degrees. And that has to be 0. Right? So we've taken our system of interest, we've identified the external forces, we've made sure because it's not moving, all of those forces end up balancing by enforcing these two equations. We can find out the T2 and the T1. Why? We haven't done that yet, but here we have one equation, two equations, and we have two unknowns. Since we have two equations and two unknowns, we can now determine what those unknowns are. Finally, closing out this chapter, there are 4 basic forces in the universe, and everything you experience as a force is basically an expression of one of these. There's gravity. So gravity is by far the weakest on a sort of individual microscopic level. Gravity is by far the weakest. However, because we live on a very large planet in terms of our size, gravity is a dominant force in most of our lives, right? Electromagnetic forces, right? Gravity can also be only attractive, so that also helps it out on that. Electromagnetic forces can be attractive or repulsive. We'll get to that. Electromagnetic forces are actually what keep your hands from going through your desktop. We'll eventually talk about that, but that's on in the second semester. Weak nuclear force, well, we don't really have to worry about that in this class. And the strong nuclear force, we'll talk about some. And these we will get to, weak and strong nuclear forces, at the end of the second semester. So that's it for all the 4 forces. Gravity is the one we're going to talk about the most often. The others that we talk about are in fact a result of these, but we're not going to get into those details usually. So that's it for Newton's laws. Please remember, a body at rest will tend to stay at rest and unless acted upon by an external force. A body in motion will remain in motion at constant velocity unless acted upon by an external force. This is Newton's second law. The net force on a system equals its mass times its acceleration. Right? That's Newton's second law. And Newton's third law, every action has an equal and opposite reaction. All right, that's it for chapter 4. Enjoy.